Hello class, today we're going to be learning lessons 2-3 and 2-4 in your textbooks that are talking about how to solve two-step equations and multi-step equations. We've done one-step equations already. Those are fairly simple and we're able to do them rather quickly. So now moving on to two-step equations, there's multiple things you're going to need to do. So what I want you to remember is first to get rid of the lonely number. This is a number that is not touching the variable, okay? And so normally to get rid of that, you're going to either use addition or subtraction. So let's try to remember that's our first priority, is to get rid of this lonely number, move it to the other side of the equation. Then the second step that I want you to remember is to get rid of the touching number. So the number that in some way is touching our variable. And you're going to do this by either multiplication or division. Okay, I forgot the number sign there. I'm sorry. So then for our end result, we're going to finally get down to our variable equals some number for our solution. Okay, this is still what we're trying to achieve in the very end. So why don't we do a couple practice problems together? Our first equation says solve 5x plus 9 equal to 24. Okay, let me move that up a little bit. So following my steps at the top, first I'm going to get rid of the lonely number. The lonely number is 9. I'm adding 9. It's not touching the variable. So instead I want to subtract 9 on both sides first. All right. Those will cancel out. And I'm going to rewrite what I have. I have 5x is now equal to what? Looks like 15. Right? If I divide both sides by 5, then in the end, I'm going to come out with x is equal to the number 3. I'm not entirely certain if that's correct, so let's check our work. We're always going to rewrite the equation. 5x plus 9 is equal to 24. And when I plug in this 3, I want to make sure that this whole left side equals 24. So 5 times 3 plus 9, does that equal 24? Well, that's 15 plus 9. And yes, this right here does equal 24, which matches the right-hand side. So I did solve this equation correctly. So again, it's really important to get rid of that lonely number first. That's what I really want you to remember, instead of trying to divide everything by 5. If you do that, you're going to be left with some messy fractions. All right, our next equation says to solve -1 equal to 7, or z divided by 3 minus 7. Okay, so this time it looks like our variable is on the opposite side, but that's okay. Still, I want to get rid of the lonely number that's not touching the variable. So in this case, it's subtracting 7, so I want to add 7 to both sides. The 7's cancel each other out. And on the left-hand side, now I have -1 plus 7, which is 6, is equal to z divided by 3. Now I can do my second step. And my second step is going to be multiplying both sides by 3 so I can get z by itself. So in the end, I have that z is equal to 18. And so just like we did before, let's go ahead and check our work by plugging it in. So I have -1 is equal to z over 3 minus 7. Let's try to plug in that 18. And see if it'll equal -1. 18 divided by 3 is 6, and 6 minus 7 is -1. So I did find the right answer. Awesome. Let's go ahead and do another one. This one says solve 7x minus 4x equal to 21. Now this time you're going to see that I have two variables on the same side. So in this case, what I want you to remember is to combine the variables. Okay. I don't have any lonely numbers on this left-hand side, but I do have two different variable expressions, so I'm going to put them together. What's 7x minus 4x? Well, you just look at the number, the coefficient right in front, and subtract them. 7 minus 4 is 3x, and that's equal to the right side, which is 21. Now I have a one-step equation. Divide by 3, divide by 3, and we're going to find that x is equal to 7. Let's go ahead and check to make sure that our solution does work out. Rewrite what I have. 7x minus 4x is equal to 21. When I plug in 7, we want to see if it matches this right-hand side. That's why I put a question mark. Let's see. 7 times 7 is 49. 4 times 7 is 28. And 49 minus 28, yep, that is 21. So I did find the correct solution. It is x is equal to 7. Awesome. So now let's move on to something else. This time it kind of looks like a word problem, but it's not. This is a verbal phrase, and we've practiced a lot with translating verbal phrases into a mathematical expression or sometimes an equation. So let's see what it's asking us to do. It says the output of a function is 3 less than 5 times the input. Okay? Do you remember what output and input are? Find the input when the output is 17. Okay? So the input again is my x, the output is my y. So let's try to write this as a verbal phrase first. So let's see here. The output of a function is 3 less. So this means that y is, that means equals, 3 less than 5 times the input. So that means 5 times the input, which is x, and 3 less than it. Okay? So first I just translated that beginning sentence into an equation, and then it's asking me find the input, so it wants to find x when the output, when y is 17. So I'm just going to plug in then and substitute y for 17, because it says that the output is 17, and when that happens I want to find out what the input is. So I want to find out what x is. And now this looks just like an equation we just worked with. So I want to get rid of my lonely number, which is subtracting 3, so I'm going to add 3 instead. Those cancel each other out. On the left-hand side, 17 plus 3 is 20, which is equal to 5x. Divide both sides by 5. And in the end, I find that my x is equal to 4. So let's go ahead and check to make sure that this is true. So I have 17 is equal to 5x minus 3. I'm going to plug in x equal to 4 and see if that equals 17. So let's see here. That is 20 minus 3, and yep, 20 minus 3 is 17. So I did find the correct solution. All right, you're definitely going to be able to do these, and you're going to get a lot of practice today in your classwork. So now we're moving on to some multi-step equations. And they're very, very similar, okay? I guess if I was going to give you some tips, I would say, again, that I want you to combine the variables. That's one of your goals, okay? I also want you to move the lonely numbers to the other side. So let me just show you an example of what I mean. So now I have a combination of two different sets of variables and a lonely number, and then a number on the opposite side of the equation. So at the beginning, I'm asked to solve this. So why don't we combine our variables? It looks like that's pretty easy to do. 8x minus 3x is going to be 5x. And then I'm going to rewrite the minus 10 equal to 20. Okay, now it looks like my two-step equation. I'm going to get rid of this lonely number, so I'm going to get rid of the 10 by adding 10 to both sides. Rewrite it. 5x is equal to 30. One step left, divide both sides by 5, and x is going to equal 6. So now let's check our work. We're going to do this every single time. Rewrite the equation. I want to find out that when I plug it in and work it out, if it equals 20. Times 6 minus 10 is equal to 20. I'm going to put a question mark there because I don't know it yet. 8 times 6 is 48. 3 times 6 is 18. Minus 10, is this equal to 20? Well, let's see. 48 minus 18 is 30, and 30 minus 10 is 20. Yep, works out perfectly. Awesome. So here's another one that we're going to try. This one says 4x minus 7 times the quantity x minus 2 is equal to 26. For a problem like this, I would say use the distributive property first. Okay. Just kind of a side note there. And the reason is because I can't combine the x's, the variables, until I do the distributive property, which means I need to multiply the 7 all the way through. But notice right here, there's a negative sign in front of it. It's minus 7, which means when I do the distributive property, I need to include that negative symbol. So I'm going to rewrite this as 4x. And then I'm going to say to myself, what is negative 7 times x? Well, that is negative 7x. And then again, what is negative 7 times negative 2? Well, that's positive 14. I got to say that right here, that would be one of the biggest errors that people make. So I'm going to put a whole bunch of stars there. Make sure you always remember, if there's a minus sign there, that this is really going to be a negative number you're distributing through. And this is going to be equal to 26. Now I can combine my variables. 4x minus 7x is negative 3x plus 14 is equal to 26. Now I can move my lonely number. So I'm going to subtract 14 on both sides. And I'm left with negative 3x is equal to what? 12. Awesome. Divide both sides by negative 3. Almost done. X is equal to negative 4. At least that's what I think. So just like you, I'm going to go back and I'm going to check my work. Because if you do this, you're always going to know if your answer is right. So let's rewrite our beginning equation. 4x minus 7 times the quantity x minus 2 is equal to 26. Let's plug this in. 4 times negative 4 minus 7 times negative 4 minus 2. Is that equal to 26? This is our longest one so far. So here we go. 4 times negative 4, that's negative 16. Minus 7 times negative 4 times or minus 2 is negative 6. Is that still equal to 26? Doesn't look like it so far, but maybe it is. Now I have negative 16. And this right here I'm going to turn to plus negative. So now really I have plus, what is negative 7 times negative 6? Well, that's 42. So now it's looking more like I possibly got the correct answer. Negative 16 plus 42 is 26. So I did find my correct solution. Okay. We're going to do one more problem together now. And then we're going to be done. So for this problem, it says a fraction 3/4 times the quantity z minus 6 is equal to 12. So you could do the distributive property here, but it would get a little messy. Okay. Mainly just because when I distribute the 3/4 times the 6, I'm going to get 18/4, which is not a nice number to work with. So instead, what I want you to do when you see a fraction on the outside is multiply both sides by the reciprocal. That way you don't have to distribute a fraction. So instead of me distributing, I'm going to multiply both sides by 4 over 3. Okay, so now those will just cross each other out, and I'm going to rewrite what I have. Z minus 6 is now equal to, well, let's see, 12 and 3 cross cancel, and 4 times 4 is 16. Isn't that so much easier? That's awesome. Okay, one more step. Get rid of the lonely number. I'm going to add 6. Those 6's cancel out, and I'm left with Z is equal to, what is 16 plus 6? 22. I don't know if that's right. So our last problem, let's go ahead and check it. 3/4 Z minus 6 is equal to 12. Let's plug in our 22. And see if this is going to be equal to 12. Okay, do inside parentheses first. What is 22 minus 6? 16. The 4 and the 16 can cancel, and I'm left with 3 times 4, which is 12. So I did find the correct solution. So that's what we're working on today. It's 2 sections. I know it's a lot, but they're both very similar to one another. So on your own, before you come back to class, I have 3 problems for you to try. 3 different types of problems from this section. So go ahead and try those on your own, and I'll check them when we come back to class.